Yes, dear friends, in this video, in this lesson, we have a capacitor and conductor connected in series across AC source whose voltage equal to V equal to V sin omega t. We have learned in previous video that in case of capacitor voltage lags behind the current by pi by 2. In case of resistance, current voltage are in the same phase. So directly I write here, if it is I, then VR is this way and VC this way here. VR and VC are RMS value of voltage. If we connect here a voltmeter that reads the RMS value of source, I am telling again you that here this V is the instantaneous value and it is the sum of instantaneous value of this and this, and that way you can write it is Q by C, QT by C plus ITR. Okay. It is IXC plus IR equal to V0 sin omega t. These are the instantaneous values. XC, capacitive reactance, resistance. But what are these? These are the RMS voltage. VCBR, IXC instantaneous voltage of capacitor, IR instant voltage across conductor. Now the vector sum of these two will be given by this diagram. V phi. So resultant voltage vector sum of the RMS voltage of across conductor and capacitor is given by under root VR square plus VC square. But VR, IR, I is the RMS value. Here this I is the RMS value. I told you if you are asked to find current in circuit, then you need to find RMS value. And VC, IXC. So what is V here? Now this V equal to under root I square R square plus I square XC square, or V equal to I under root R square plus V upon I equal to R square plus XC square. Here V upon I equal to Z. That is impedance. Z is called impedance of series CR circuit. And so here Z is equal to the root Z is equal to under root R square plus XC square. Now this phase angle between current voltage Z is equal to R square plus XC, and you know X is equal to 1 upon omega C. Do a good practice of calculation of XC. Once there was a question of 3 marks to calculate the capacitive reactance for a capacitor of 200 microfarad for a frequency of 60 Hertz. C was 32 microfarad and F equal to 60 Hertz. इसके लिए एक्सी पूछा कैलकुलेशन students left because they were unable to divide. So please learn things sincerely. Do calculate this value for the data. Omega 2 pi होता है, तो x is equal to 1/2 pi fc. Calculate this. Now, phase difference between current and voltage. Phase difference between current and voltage. Tan phi equal to xc upon, sorry, must I write bc upon br. Tan is trigonometry. It is I xc upon ir, or tan phi equal to xc upon r. So phase difference, if we know phase difference, we can find out time lag also. So this was about series CR circuit. Now I am going to discuss very important topic. That is series combination of inductor and capacitor. Series combination of inductor and capacitor across AC source. This chapter is not only important because we are using electricity. This chapter will make you learn so many things. Our communication is through electromagnetic wave, which consists of electric field, magnetic field, which keep on changing with a very high frequency. वो भी AC वोल्टेज मिलते हैं वहाँ पे, उसको डिस्कस होगा. But see what is happening here. It is inductor, this is capacitor, and it is AC source. In case of inductor, you know, voltage leads the current by pi by 2. In case of capacitor, voltage lag behind. I think I don't need to write here. Save time of the video. In case of inductor, you know, voltage leads the current by pi by 2. In case of capacitor, voltage lag behind the current by pi by 2. So vector diagram can be drawn like this here. Okay, if it is I, here is the VL, and here it is VC, suppose. So when two vectors are in opposite direction, then the resultant will be the difference. So these are, again I am telling, RMS voltage. यानी RMS voltage. So RMS voltage which a voltmeter will read when we connect across the two, that V will be RMS, the resultant voltage V equal to VL minus VC, if VL more than VC, or V equal to VC minus VL. It is not necessary that only always VL will be more. In general, VC is greater always. Or here IZ equal to IXL minus XC. So Z equal to XL minus XC. Here also Z equal to here XC minus XL. ये कब होगा? When XC more than XL, VC more than VL. In that case, the reactance, जैसे Z is the resultant impedance कह लीजिए या resultant reactance. They represent reactance here. Now what happens if, and further you know, XC, both depend on frequency. Now, if you remember, there is a graph between, if I plot the graph for F and XL and XC on the same. So XL graph will go like this for a given inductor. Because XL equal to 2 pi FL. When we increase frequency, XL will increase. Is that clear? Or XC equal to 1 upon 2 pi FC. I am writing again and again the equations so that you should learn it here only. Then the graph of these two will be like this. And remember XL minus XC. If XL this way, XC this way. They are in opposite direction. R is this way. अगर R होगा तो यहाँ नहीं है R, इधर है ना. So they are in opposite direction means if value of the, I told you these are all vectors. If XL is from left to right, XL is right to left. And at this frequency, what is happening? The two are equal. XL and XC equal होंगे हम. And this frequency here is called FR, resonant frequency कहते हैं इसको. I will tell what is the meaning of resonance. So when, actually by inductor capacitor connected AC source, if we have a source of variable frequency, variable, then at some frequency of a source, they will be equal. And then VL, V equal to VL minus VC, or VL VC बराबर there, or IZ equal to 0, or Z equal to 0. I will be there, but in reactance 0. I will be infinity in one sense. Large current होगा. This condition is called resonance in series LR circuit. LC circuit, sorry, एक minute में. Yes, dear student, now, so I was telling what is happening here. So I call it resonance condition. What is resonance in fact? It is very important to learn here. What is resonance? Here, if I come at resonance condition, XL equal to XC, so you get 2 pi FR L, 1 upon 2 pi FR C, or FR here will now be under root, ये हो जाएगा. The value of resonant frequency depend on L and R, and is called natural frequency. Who will be oscillating? Electrons are oscillating. When we connect a series CR circuit, LC circuit, if we connect here series LC circuit and we apply source So source frequency is fixed. So electron oscillate with on frequency, but later on, very soon, if this frequency determined by value of L and C, which is called natural frequency, does not match frequency of source, then electrons oscillating here will pick up the frequency of source, and that is not resonance. Resonance will take place only when source frequency become equal to the frequency given by this equation. A natural frequency, बच्चे समझ नहीं पाते. I'm giving one example more. You have seen the strings or simple pendulum. Time for pendulum 2 pi under root L over G, or n equal to 1 upon 2 pi under root G by L. So this frequency of pendulum depends on length L of pendulum. If you increase the length, frequency will change, decrease, and it will go slow. You might have seen long swings and shorter swing, jhule. Longer swing has that slowly move, has low frequency. So the frequency of any oscillatory body determined from its structure is called natural frequency. So here, when we pass electric current through this series circuit, electrons start oscillating with this frequency. If this frequency matches with source frequency, then reactance becomes zero. Current will become infinity. Large current flows because infinity because some resistance is there. But large current flow, and this phenomena is called resonance. Resonance is the phenomena of force oscillation, force vibration, in which the frequency of oscillating body becomes equal to frequency of AC source. So this is resonance here, and we use it in tuning our television, in tuning our telephone, in tuning our radio transistor with the wave which we are receiving. Our communication of television is through electromagnetic wave. Our antenna is of metal. Metals have free electrons, and those free electrons there start oscillating because of electric field of the wave keep on changing in magnitude direction, left to right, right to left. So electrons also oscillate, and that we get an AC current of the frequency of PM wave. In our television circuit, there is AC circuit. Now by changing the value of C or L, we can change the natural frequency, and for the if the frequency of this circuit matches with frequency of any channel, for that sound will be large, picture will be bright. For others, that will not be seen. So I will tell you later on the same thing. So I have discussed the series combination of resistance and inductor, capacitor and resistance and LC. So now I will come in next video, series combination of LCR across AC source. Thank you.